So in this video, we're going to show an example of the calculation of a Riemann sum. Suppose we have the function f of x equals e to the x, and we're considering the interval from x equals 0 to x equals 2, and we're going to have a calculation involving 20 rectangles using a left-hand sum. Well, of course, the very first thing we need to do is just figure out those x coordinates. So just imagine, here's the interval going from 0 to 2, and we're going to divide this into 20 individual segments. So that means each segment is going to have a width of 1/10. Since we're taking the left-hand sum, that means that the first term will be 0, the second will be 0.1, then 0.2, all the way up to the last one, which will be 1.9. Those will be the x sub i's. Of course, that last one is 1/10 before 2. If we were doing a right-hand sum, incidentally, it would start at 0.1, and it would be 0.1, 0.2, 0.3, and it would actually go up to 2. If we were doing a midpoint sum, then that's a little trickier. The first one would actually be at 0.05, and then 0.15, 0.25, all the way up to 1.95. But here we have a left-hand sum, so we have figured out the x coordinates. Well, step 2 would be to plug that whole list of x coordinates into f of x. So we would want f of 0, f of 0.1, f of 0.2, etc. And you could do this on a calculator very easily using the list commands. Just plug the whole list into the function in one fell swoop and get a new list of the values. Once we have that list of values, then what we're going to do is, those are all the heights of the Riemann rectangles. And of course the width is 1/10. So to find the area, we have to take that whole list and we have to multiply it by 1/10. Then when we multiply by 1/10, we take the sum, and the sum I get after summing all this up is something along the lines of this. This is the sum of 20 rectangles using a left-hand sum. And that's a good approximation for the area. The actual real area, which we'll talk about how to find in a few videos, the real area is this. So notice that we've come reasonably close using left-hand sum. And probably a midpoint sum would give us a more accurate calculation of the area than this left-handed sum. So this is an example of how to do the calculation associated with a Riemann sum.